I am.
Yeah, Ed is.
Yeah.
Okay. Is there anyone else? All right. Well, I'm going to.
I'm doing the dead astronomer, Chandra Sakar.
Okay, great. Just a few little quick announcements. I'm Daryl Heath, and I'm the club president for this year. I like all the rest of you. We're still looking forward to when we can get back together and meet in person. Hopefully we can do that before too long. We are talking about it, so it's in the near future, I think.
Just as a show of hands, how many people have been vaccinated now? Yeah, see, so somewhere, yeah, there I am. So good. So really, we're probably getting pretty close to where we could do it.
Yeah, I've not only been vaccinated, I've been exposed to it and had some little symptoms with it. That was back in earlier in the year, last year actually. But anyway, the Texas Star Party is going on right now. They're doing that virtually, and they're doing it right now, as a matter of fact. And I think they're going up till late this evening. So after this meeting, if you want to take part in that, go over. I think Sky and Telescope has a link where you can join in and participate in that. They've been doing it for the past 3 nights. So the previous nights are on YouTube. Feel free to watch those. A lot of cool things going on there. John, you've been to the Texas Star Party before. Several of you have as well. So it's a good event, right?
Oh God, it's a hoot. Yeah, it's the biggest, of course. And I think it got up to like 800 people, and they started limiting the people that could go to the ranch. Now, that sort of dialed it back because people would get frustrated if they were on a waiting list. It actually was a self-correcting problem, but it still is. It's bigger than Okie-Tex if you've been to that one, and it's yeah, it's something else. And it just the number of telescopes and equipment and you know, you could not do any observing and just have a fun time just going around looking at equipment, especially if you're a gearhead like I am.
It's
But,
ideally situated
yeah,
in the Davis Mountains, so it's some of the darkest skies in North America. And
it is very dark. And in fact, I wrote an article about it for Sky and Telescope years ago that they published. And it is amazing. Yeah, it's just hard to describe the sky and so forth. But
yeah, I've been up to the McDonald Observatory. Yeah, it's stunning. So if you ever get a chance, any of you have not been before, and you get a chance to go out there in that area, please do. It's something you will not forget.
There's a nice campground at Fort Davis
Yep,
too.
Fort Davis.
Campground, and there's a little motel at the
Yeah,
state park too.
There's the
Yeah.
Indian Lodge there at
The Indian
yeah,
Lodge,
the
that's
state
right.
park is just right down the road from the ranch where they have the Star Party.
And there are
It's
hotels in
a
there.
cool area. I like it. It's kind of far,
It
to
is.
say the least.
You do have to travel to get to dark skies these days.
Yeah.
Ed, I'm going to let Michael go first, and then I'll go after him, and then we'll follow up with you. Is that all right? Okay. I want to ask everyone to please mute your microphones at this point, and then I'm going to turn it over to Michael and let him talk. Michael.
All right, hang on. So let me share screen. There it is. Whoop. Nope, that's not it.
We got you.
You got it?
Yeah.
The one that says Subramanian Chandra Sakar?
Yep.
Okay, good. So that's my dead astronomer. Subramanian Chandra Sakar is an Indian American astrophysicist. You can see he's born in 1910, passed away in 1995. Ooh, why is my thing not advancing? Hang on. There we go. So a synopsis of a really great astrophysicist. He did most of his work in the United States. He was a longtime professor at the University of Chicago, and he became a US citizen in 1953. His real contribution, he developed many critical models and led to the understanding of stellar evolution, especially for larger stars, stars that are like, larger than a solar mass. He is best known for what we refer to as the Chandrasekhar limit, and that's the limit of the stellar mass that will allow a star to become a neutron star or a supernova. I'll say more about that later. He won the Nobel Prize for Physics in 1983, and he won the Copley Medal in 1984. So the Chandrasekhar limit, whether that's fair that he's most known for that, but he is, because it carries his name. Prior to around 1930, astronomers really assumed that gravity caused all stars to contract after they no longer had sufficient hydrogen or helium for nuclear fusion, and they would then become a white dwarf. And a white dwarf is about Earth size, it turns out, and a density of 1 × 10⁹ kilograms per meter cubed, which is 1,000,000 times denser than the average density of the Earth. But around the era of 1930, Dr. Chandrasekhar said something's not right there, and he played around with the physics, and he really developed a very solid model that showed that stars who had a mass more than 1.44 solar masses, which is now known as the Chandrasekhar limit, would not become a white dwarf, but they would go on to produce a type 1 supernova, and their gravitational collapse after the nova would eventually become a neutron star, not a white dwarf. At the time, the model was extremely controversial and generated a lot of discussions, but it proved he was correct. He eventually did that. So, and that was really the basis for what he ultimately got the Nobel Prize for. But he did so much more beyond the Chandrasekhar limit. He developed models that really were critical to understanding stellar evolution of more massive stars, anything from 1.5 solar masses up to several hundred solar masses. And he was critical to understanding how neutron stars and black holes form and how they influence the space-time that surrounds them. He also did a lot to expand quantum theory for non-astrophysical applications, and really elucidated how general relativity applied to events in the universe, including black hole formation, gravitational lenses, and gravitational waves, things that are really on the top of the list of astronomical news today. We all know that recently we were able to finally observe gravitational waves. Well, he told us what we were going to see, and his theories have all proven true. Interestingly, his Nobel Prize was awarded for the earlier work associated with developing the Chandrasekhar limit, and really didn't mention his later work, and he was really perturbed by this. And his later work was arguably far more impactful than the earlier work, and this bothered him quite significantly. Dr. Chandrasekhar was known as a tough but excellent teacher. In fact, 2 of his students, Song-Dao Li and Chen Yingyang, both received Nobel Prizes before Chandrasekhar received his. And he was not a jealous man, from what I heard. He was so proud of his students, and he told them that. And it didn't matter that he had not gotten his Nobel Prize yet, or that his students got it before him. In fact, he seemed elated at it. Now, he had a habit and reputation that if his students were unprepared and they asked frivolous questions, or they could not answer questions he posed to them, he gave them illogical answers, he rebuked them severely. Whereas if they were well prepared, he rewarded them very much. He was kinder to students of other professors or at other institutions, and I can attest to that because I had the privilege of meeting Dr. Chandrasekhar twice when I was a student at the University of Illinois Urbana-Champaign, both in 1972 and 1976. On both occasions, he came to the university to give a presentation. He gave a great talk, and he always took like a 2 or 3 hour session. He would sit down with students and we would discuss things. Well, in 1972, that was my freshman year, and I just sat there and listened attentively. I was not going to offer up any questions or offer to answer any questions that he posed. But by 1976, I had already received my degree in astronomy and astrophysics, and was actually still finishing up my biology degree as I prepared for a PhD in biophysics. And so, yeah, I did ask a few questions of him, and when he threw a couple of questions out, I answered. In fact, he was really, he looked taken aback by one question talking about movement of material in stars, which involved sound waves. And that's because I already started working in the laboratory where I was going to do my PhD, which was a bioacoustics laboratory where I'd already started taking acoustics courses. And so I had enough of an understanding of acoustics where I could address his question. And that was fun. During that night, we had a reception for Dr. Chandrasekhar at one of my professors' house, Jim Turin. And as we were at the thing, we were talking, and he came up to me and he says that I would have made a good astronomer and astrophysicist if I had not decided to pursue my PhD in biophysics. And he clapped me on the shoulder when he said that, and I really remember that compliment very fondly. It was genuine from him. I wrote a letter to congratulate him in 1983 when he won his Nobel Prize, but I never received a response from him, and I never had any further personal contact with him. Regardless, he really remains one of my heroes of science and is an immensely impactful astrophysicist. And I'll end with that. Anyone has any questions?
Yeah, Michael, tell us a little bit about sort of the man's personal life. What got him into astrophysics?
His uncle, I can't remember his uncle's name, won the Nobel Prize for Physics in 1930. And he was very fond of his uncle and would often talk with him. And his uncle really had a big influence. That's what I remember him telling us, that his uncle had a great influence on him becoming a physicist himself. But unlike his uncle, who was more into electromagnetism and things like that, Dr. Chandrasekhar really took to astronomy and astrophysics.
Any other questions for Michael? All right. Well, thank you, Mike.
Oh, you're very welcome.
Good presentation.
See if I can share my screen here. Okay, can you see that okay? Okay, good. All right, so I'm talking about Delphinus, or Delphinus, however you want to pronounce it, with the constellation of the month. And let's see, how do I get this to advance? For some reason, this map locks up when I do.
Try hitting the down arrow key if you have one.
Yeah, I am, but it's not doing anything. Let me try this. Close that, and there we go. Is that working okay? All right. So the name Delphinus is the Latinized form of the Greek word for dolphin. It's a constellation that's best seen in our northern hemisphere summer sky, and you can see it right on up through the fall. Right now, this time of year, the best time to look for it is around midnight, and it'll climb higher in the sky as the hours progress. And when we get into July, it starts popping up in our evening sky. It's one of the 48 constellations as cataloged by Ptolemy. And it's a very small constellation, occupies about 109 square degrees upon the sky, so that's about 0.05% of the sky. And it's made up of 5 fairly bright stars. They're only around 4th magnitude, so you're going to have fairly decent dark skies in order to see it. And once again, it's not doing anything. Bear with me. There we go. Okay, so the Greeks, of course, lived right along the Mediterranean, so they made their living by the sea and in the sea. They were sailors, they were fishermen. Their whole livelihood depended upon the ocean. And so they were quite familiar with a lot of different sea life, including dolphins. Now, dolphins have an interesting behavior where they show altruism. They will help other animals, not only members of their own kind, but other species as well. And here's an example from a couple of years ago down in Florida. This small dog that you see fell off of a pier. There was no way it could get back up. It had been in the water for 15 hours before anyone noticed that there was a pod of dolphins swimming around it. And they noticed that some of the dolphins were taking turns coming up and lifting the dog out of the water every time it was about to go under. Eventually, people called in the Coast Guard, and they came to the rescue and got the dog out of the water. And you can see the dolphin saying goodbye there. But yeah, this is an interesting behavior that a lot of cetaceans show, especially in dolphins. We don't know why they do this, but they are well known for doing it. And they are known for rescuing human beings. So there are two myths that are associated with Delphinus. One is that there was a musician named Arion, and Arion was well known for being a fabulous lyre player. He played the harp-like instrument. He was kind of like a rock star. So he traveled all across the continent there, doing his performances, and he had done a gig for several weeks, and he earned a lot of money. So he was going to go back home to whichever island it was he lived on, but he hired a ship to take him back home. Well, it turns out the crew of this ship were a little bit on the sketchy side. And so they decided that they had this rich passenger. No one's going to, miss him if he falls overboard or whatever. And they would just take his money. And that's what they did. They threw him overboard. And so there he was in the middle of the Mediterranean, out in the middle of nowhere, and he's about to drown. When along come these dolphins and rescue him and take him to shore. Now, I'm sure that to the minds of the people of the ancient world, when something like that happened, and they couldn't explain why a dolphin would behave like that, they would interpret it as it was an act of one of the gods. It was the gods intervening into our lives and using this dolphin as their tool in order to do that. And the dolphins had a reputation for being helpful animals anyway. And another myth associated with Delphinus is that of the god Poseidon. And after he and Zeus and all the others overthrew Zeus's father Kronos, Poseidon went back to his kingdom. He had a nice big palace. He's sitting around there and he's all alone. He's thinking, it'd be nice to have a wife to keep me company. So he falls in love with one of the sea nymphs, Amphitrite is her name. And Amphitrite didn't want to have anything to do with Poseidon, so she went off and hid amongst some of her fellow Nereids, sea nymphs, and that caused Poseidon to get a little upset. So he sends out animals to start looking for her. And it's the dolphin who finds her and coaxes her back, and they eventually get married. They live happily ever after. And as a reward, Poseidon places the dolphin in the sky so that we'll see them and we'll know the kind deed that he did for Poseidon for all eternity. Okay. So locating Delphinus is actually pretty easy. All you need to do is find the three bright stars that make up the summer triangle, Deneb in the tail of Cygnus the swan, Vega in the lyre, the constellation of Lyra, the harp, and Altair in the constellation of Aquila, the eagle. And Delphinus just lies just to the east of Altair. It's made up of these 5 stars, and 4 of them make a diamond-shaped pattern. That's the body of the dolphin. And then if you draw a line down to the next brightest star, Epsilon, or as it's also known, Aldolphin, which is that means the tail of dolphin. You can easily imagine that this is the shape or the outline of a dolphin leaping out of the water. But that diamond-shaped pattern also is an asterism known as Job's coffin. No one seems to know where this originated from. It goes back a long ways, but there's no records as to its exact origins. But it does go by the name of Job's coffin. I'm sorry, Jim. I thought I heard someone about to say
No,
something.
I'm watching the Central Arkansas Astronomical Society's monthly meeting.
But anyway, so these 5 stars that make
Talking
up the
about
body of the dolphin
a constellation.
are Rotanev, Sualosin. I can't pronounce that. No one really can. I'll explain why in just a second. Gamma Delphini, Aldolphin, and Delta Delphini. And going back to Rotanev or Sualasin, the alpha star, and Rotanev, the beta star. The reason they have these weird names is due to this guy that you see over on the right-hand side of the screen. And that is Niccolo Cacciatore. Niccolo worked in the Palermo Observatory in Italy. At one point, he was charged with revising this catalog of stars for its 2nd edition. And he decided he was going to rename a couple of stars. And he named them Sualaisen and Rotanev. And it went into publication. Astronomers were like, what the, what are these names? And it wasn't about a century later that another astronomer finally worked it out. Niccolo was common during the time, he had Latinized his name. And he spelled them backwards. First name, Nicholas, and Venator, his last name, the Latinized form. So he kind of named them after himself, but spelled the name backwards. So no one would notice, I guess, but someone eventually did. So yeah, he's a little bit of an impudent rascal there, that old Niccolo. But anyway, all of these stars, or most of them, are binary stars, by the way. One in particular I want to draw your attention to. Well, most of these you need like either an interferometer or a spectroscope to pick them apart. Although Rotanev actually can be picked apart if you have a very large telescope. But Gamma Delphini is a very nice, lovely binary that you can see with a small telescope. You can easily split it, I think, with a 4 or 6 inch telescope, but larger scopes will give you a better view. One of them is kind of a yellow color, and another one is kind of a nice, warm, golden color. It's a very pretty little pair. If you get a chance to check those out, please do. There's another star I want to draw your attention to. 18 Delphi. There's about 40 or so stars that are associated with or within the borders of the constellation of Delphinus. But this one in particular is kind of interesting because it's got a planet, an exoplanet orbiting around it. So this is 18 Delphini, and several years ago, the International Astronomical Union decided to have, this is something very rare for the IAU to do. They had a naming contest. They opened it up to where students could name some of these planets, these exoplanets orbiting around other stars. And it was a school group, a high school group in Japan who got the winning pick out of this lot of names that had been solicited. They decided to name it Arion. And as you'll recall, Arion is the musician in one of the myths where he got thrown overboard in the dolphin rescue. So this planet has the official name, at least recognized by the IAU, as Arion. There are no Messier objects in the borders of Delphinus, but there are a few interesting deep sky objects. Over on the top right, you'll see a globular cluster. There are a couple of those. They're both Caldwell objects in the Caldwell catalog. So we've got Caldwell 47, Caldwell 42. Caldwell 47 is about 52,000 light years away, has a magnitude of about 8.83. And Caldwell 42 is 170,000 light years away. And all of these are orbiting around the halo of our galaxy with a magnitude of about 10.6. So you're probably going to need a decent size scope and decent magnification to see them, but you might want to check those out. There are also a couple of planetary nebulae. The one on the left that you see here, that is NGC 6905. And if you're not familiar with what planetary nebulae are, these are the end product of dying stars that are much like the sun. Stars have pretty much the same mass. And once they've expended all the fusible material in their cores, they start sloughing off their outer layers, exposing the central white hot core, which is then known as a white dwarf. And the radiation from that white hot core, and you can see it here in this picture, excites the atoms, it ionizes the atoms in the cloud of shells that are surrounding the white dwarf and make it glow. And there's a lot of different planetary nebulae in the sky, but this is a nice one to check out if you can. The other one that you see down in the lower right is called the Blue Flash Nebula. And it was actually discovered by William Herschel, the guy who actually coined the term planetary nebula. He discovered this one back in 1784. And it has a bit of a more intricate design to it, as you can notice there. But let's see, I think that's about all I have. Yep. And does anyone have any questions you want to ask? Rocky, if you got any comments you want to add, sites we should see around Delphinus? You need to unmute.
I just wanted to say that it's all 5 stars are pretty equal, and it's pretty easy to see even in moderately light skies. So it's an easy constellation to find.
It's one of my favorites. I think it was one of the first ones that I found on my own back when I first started getting into the hobby, that it wasn't one of the big, bright, showy, conspicuous constellations. And then once I picked it out, I could get Sagitta right next door to it, and some of the others that were around there. So yeah, it's one of my favorites. It is a nice, showy little constellation.
There was a nice nova in it, what, 10 or 15 years ago?
Yeah. Well, I think it was more recent than that, wasn't it?
Was it?
Yeah, I remember that one.
It's one of the rare,
It might be that far back.
one of the rare constellations that look like what it's supposed to be.
Right.
Yeah.
I was just looking up this Blue Flash Nebula. You know, you said that, and I was thinking of the Blinking Nebula. Totally different, of course.
Right.
I don't know why it's called the Blue Flash.
Well, apparently there was an amateur astronomer who gave it that name back in the 1960s, and it just kind of stuck. It's not actually flashing. It's just a name that he gave to it in an article he wrote, I think maybe for Sky and Tel. And like I said, it just kind of stuck.
I've looked at both globular clusters in Delphinus, and they're actually fairly easy to find and look at. I've not looked at the planetary nebula, so it looks like we've got some good weather coming up next week, Daryl. So I'm gonna, those are on my list now to go look at. Thank you.
Believe that forecast. It's good.
I hope so, Jim. I really do.
It was supposed to be clear last night.
Yeah. I fell into that trap too. I was heading out, actually driving down the road when I looked up and said, it's not clear. Turned around and went back home. Okay.
Nova Delphinus was 2013 and got up to magnitude 4.5.
Yeah, I remember it. I remember going outside and looking at it. Okay, I'm now going to turn it over to Ed.
All right. I'm going to talk about something I've done to find things with my Dobsonian telescope, and it's just based on the azimuth that you're pointing at, your compass direction, and then your altitude. And I use a little thing called a Wixie that I'll talk about that's really made probably for people who are setting up something like a table saw or something like that and want to get an angle just right. Has a magnetic base on it, and I'll explain a little bit more about how that works. Let me share my screen. All right, so that's the telescope I use. That's my 10-inch Dobsonian, and the key parts of the whole process here, one, having a telephone or an iPad or something that has the coordinates of an object on it. I built a little table you can see over there on the right side of my mount where I can put, in this case, an iPad mini. Then on the base, I have really a protractor, a big, like 18-inch protractor. And then my little angle gauge, my Wixie, is up on the top of the tube on a little cradle that's slightly adjustable. The reason that I use this is because, one, I don't have go-to on my big telescope, and two, as you can see in this picture I took, there are, I think, last time I counted, over 14 open bulbs that I can see from my front yard where I've got my southern view. Several of those, about 10, are street lights. One of, and the monster street light right there that you can see in this picture is right in my face when I look to the west. And then all these people put these blue porch light bulbs in, so I can't see a doggone thing when I look up other than a handful of bright stars. So this helps me find some things because I can see the bright stuff, but there's nothing in between the star hop tube. And I'm not good at using a finder scope, so I want to use a 1-to-1 or red dot to find with, and there's nothing there. It's more relaxed than go-to. I've got some go-to mounts for smaller telescopes, but they're finicky, and you know, I kick the leg on the tripod or something after it's taken me 10 minutes to set up, and it's also just not the aperture I need to find things in the middle of Little Rock. But I still get to read charts and do a little bit of star hopping once I get to the general area of an object, if it doesn't just stick right out at me. So your telephone is the key to this whole thing. And what I use is, and I'll show it a little bit later, is Sky Safari. It looks like Stellarium. To put it on your phone may cost money. I haven't got it on a phone, but anything that you can use to give you real-time compass direction and altitude above the horizon is what you need for this. A lot of people pioneered this sort of thing with programmable calculators and then PDAs after that. So they would program those to give them instantaneous coordinates for objects. And now with smartphones, you've got it down to your location, time, everything. It's just incredible. So you can do coordinates by right ascension and declination for an equatorial type mount, but you can also get them by azimuth and, again, the altitude above the horizon where you are. This is a screenshot of my phone with Sky Safari open on it. So the key parts of this are, one, that I've centered Arcturus. So I searched for it and then said center object, or you can click on it and it highlights that object and kind of locks in on it. When it does, and that's in the circle in the middle, but over to the left-hand side, you see the yellow arrow, and that tells you that it's in the southeast at 121.6 degrees, and the altitude is 64.2 degrees above the horizon. So that tells you where to find it. Now, this is one of the stars that I can see from my front yard, obviously, but when it gets dimmer than that, if you're trying to work away from a bigger star, then that's when this really helps you, because you can see the bright stars and that helps you get oriented. So what about the telescope? Well, you know, an equatorial mount usually has setting circles on it. Michael uses those and has talked about using those manually to find things. But when you have an alt-az mount, one that just turns side to side and goes up and down, but isn't tied to your altitude in relation to, or excuse me, your position in relation to Polaris, then you don't have that same coordinate system available to you. You do need a wide field of view for this because it's horseshoes and hand grenades. It's not that precise. It's rougher than you would get with other methods of finding things. Although there are people who put vernier scales on their stuff and do all kinds of things to get super precise, but you just don't need to. I'm just trying to get to the object and not have to hunt all over the sky for it. So you do need a wide field of view so that you can find what you're looking for. And if you don't want to do anything to tinker with your telescope, you can just, if say you're looking for an object near Arcturus, you could just open your phone up, and on my iPhone, there's an application called Measure, and it has a level program on it. And you can take that and just park that on the top of your scope with your hand and get your altitude right. If you can estimate your azimuth, and I'll talk a little bit more about that. It would be great if you could just put a compass on your telescope and then point the telescope according to your compass direction, plus adjust for declination in your location. But there's enough metal in most telescopes or mounts that that big 10-inch Dobsonian I have is steel. So it is a huge interference with anything that involves magnets, including the compass on my telephone. So I could use the iPhone to get a direction, but I need to get away from cars. I need to get away from that big hunk of steel. But that would be really nice. And I know people have tried to isolate and done some things, and somebody even sells a gizmo that's supposed to isolate your phone from metal objects, but I don't know enough about physics to know whether that would work. It hadn't worked for me. So again, altitude only. You don't necessarily have to have azimuth. You can estimate that from a bright object and just work around that. But getting the altitude helps. So you could find a bright starting point like Arcturus, and then if you knew you were just a little bit to the right or left of it, if you put your phone on top of your telescope, and that's a screenshot of my level program on my phone. That way you don't have to make anything. You just use that to get in the ballpark of the object you're looking for. Azimuth, again, is just direction in degrees, and some people take something as simple as a protractor, and if they've got a round base on a mount, they'll find a way to mount that under the base. One of my kids had access to a laser cutter at school and cut me one that drops down over the base of a Vixen portamount that I have. So it puts me a protractor at the base of that, and then I know which way I'm pointing according to compass direction. The picture on the right is my circle that I printed and then had laminated, and I set that on a piece of masonite. Carl Schultz did this with one of the scopes that belongs to the club, and I think I was trying to explain to him how I made this stationary, that it holds its position while I turn the bottom of the telescope, but it's more complicated than I can explain right now. But I'll tell you why it's important in a minute or two. That cost me more than it should have, and I've got a reference at the end on a 15-year-old thread on cloudy nights on using this type of setting circle method. And a lot of that is discussion of how you can scale one of these to fit the base of your telescope and modify the size to do what you need to do. I just picked a diameter and had it printed out and laminated. So for altitude, again, I use my little Wixie. It's an electronic level. It's not lighted. Some of them are lighted, but they're lighted bright and usually greenish colored. So you still need to do something about that. I just use a little gooseneck LED light with red film over the LED and keep it pointed at it. An alternative is just a level you can get at Home Depot. It has a magnetic base for doing carpentry work. And that's what's pictured in the center toward the bottom there. Problem with these, and I've had a couple from Harbor Freight, is they don't settle down very quickly. It just has a weight opposite the pointer. And the more you move, the longer it takes to settle down. So it's a little annoying. And then I have to have 2 or 3 pairs of glasses to look at stuff anymore. So you can't see the numbers on there either. So on the right, and I have another link to a guy who has a website called Home Built Astronomy, and he has some great projects well explained on there. He made a little gizmo that I copied where I put 2 bolts through that steel telescope tube, and with washers and springs, nuts and wing nuts, and a piece of angle iron that, again, the magnetic base of that angle finder sticks right to that angle iron. And if I'm off a degree or two, when I center something in the eyepiece, I can give those wing nuts a turn or two, and it zeroes it perfectly with the altitude of the object that I'm looking at, because the tube and the optics are not necessarily physically aligned dead on with each other. So that's what you're compensating for there. So that helps. You can get pretty doggone close with that. So then the question is whether you have to level the base of your telescope for the azimuth. So that's the compass direction. And on the internet, everybody says you've got to have it perfectly level, perfectly level, perfectly level. Well, you don't, and it doesn't matter anyway. So as long as you're not too far off so that you're leaning one way or another. So if you're set up, usually out at Pinnacle, it'd be difficult because we're on that sloped parking lot. It's difficult just to have your telescope stay pointed at something on that slope parking lot too, because it tries to roll around. But if you're working within a small part of the sky, this is, again, it's a rough method of finding an object usually. So if you're slightly off kilter a little bit, you're going to lose some fraction of a degree, here and there, and then it'll add up as the farther away you get from the object that you zeroed on. But it's going to do that anyway, because again, this is not machinist level stuff. This is rough. So you always need to recalibrate as you move around the sky. So if you're working, say, around one small constellation, then you're fine for a while. You're going to recalibrate occasionally. If you make a big sweep around another part of the sky, find another bright object, recalibrate. And then you're going to bump the circle. My circle hangs up every once in a while. So it's just going to happen, and it's no big deal. It's a lot easier than when you're using a go-to telescope and you pull a wire out, or you do something like that. You've got to start all over, entering the date and all that good stuff. So leveling for altitude, absolutely unnecessary, because the azimuth reading on that level that you put on the tube is always going to be right if you calibrate it properly. So the big thing on either leveling the base or for azimuth or altitude is how far you move the telescope. I have looked and looked and looked and looked and looked for galaxies in my front yard, and there are no galaxies in my front yard. So I keep looking for these things, and then I will find an object that I can identify and then check against my circle and my degrees, and I've moved 10 degrees, or I've moved a long way hunting around, for those objects. So it's more important to be patient and to be gentle with the amount of sky that you're looking for, because you really are in the ballpark if you set this up right. So here's how you calibrate. So when you go out in the front yard or the backyard or anywhere else, for your azimuth, again, this is the compass direction. You pick a bright star, preferably in the area that you want to look at, because again, you're going to lose your calibration as you turn. So you find a bright star and go ahead and select it in your planetarium program and that will give you that reading of the altitude and the azimuth for it, and then find it in your eyepiece. So you find it in the eyepiece, you know you've got it, then you read that number, say it's 0, then you go and you turn your dial to 0, and you're on for the compass direction to that object. I've seen a lot of people who have a fixed dial on their base. And the problem with that is that you not only have to center the object in the eyepiece, but then you've got to turn the base so that the numbers are right on your dial. And I just don't know how you can do that practically without driving yourself crazy. You could, if you had a place you always set up, just like somebody who would set up an equatorial mount and they had it dialed in just perfectly, they may make marks on the ground or on the pad where they set up, so they always set up the same way. You could do that. I mean, you could set your base that way, but you really want to be able to turn that dial, and that's just too complicated to explain. I could show it to you, but I couldn't explain it. So altitude, again, you find that bright star, you look at your program, and then make sure that your altitude finding tool is right. If it's not, if it's a degree off, just remember that. Just know that you're off a degree, and compensate for it just in your mind. Again, you're going to move that thing looking for your object, so a degree or two is not going to kill you on that. So what I do, I select the object. It's right there on my telescope mount. So I usually pick it up, get it, set it on there, and I can read it as I mess with the telescope. I get my azimuth dial right, get my angle gauge right, and then when I look for something, I sweep and look for that. And occasionally recheck everything. I've surprised myself with how well this works. There's one object, a planetary nebula that I looked at that is blue. It was in the south a couple of months ago, and I can't remember which one it was. But, and I think I did it with the blinking planetary that was mentioned earlier. I got all my numbers right and looked over, and there it was. I mean, right there in the eyepiece. So that was great. Galaxies, I suspect they're in the eyepiece. I just can't see them. That I have found them, and that they're just not visible to me, even with a 10-inch mirror, because I'm in just a soup of light pollution here in town. So a couple things about, and I use Sky Safari. Everybody uses different things, but one of the great things, again, over on the upper right, upper left is where your location is of your object by the coordinates for altitude and azimuth. But when you then start looking for the object, you can use Sky Safari as your chart. And on my Newtonian telescope, I'm flipped both ways, side to side and upside down. So you go up to the upper right on the screen, and the little blue numbers there that show the field of view that you've zoomed into, 2.8 degrees by 1.5 degrees. If you click on that, and I didn't know that for a long time that it was there, but you click there and you can tell it to flip horizontally, vertically, or both. So you can flip the view. And then on the screen, the object itself, you can coordinate your field of view of your telescope and eyepiece to make sure that you are looking at the right image scale when you look. So I put Z10 into the program, and it knows it's got the specifications for just about every telescope made in my 68 degree 24 millimeter eyepiece that I really like. So with that combination, it gives me a circle exactly as big as my field of view through that eyepiece is supposed to be. And it even gives me the directions in case I sketch something so that I don't make myself crazy trying to figure out how to undo those directions back, mirrored and flipped. So here, and this is what I've looked for in my front yard that doesn't exist in my front yard, is a couple of the Messier objects that are on the urban list, but invisible. And I guess I need to go to the edge of town. But that's the beauty of this. So I can get in that ballpark, and then I can use the patterns that I can see in the eyepiece, or if I use the finder on the telescope, I could use that to zero in on the objects based on the patterns of the stars around. So I still feel like I'm doing a little bit of star hopping. What I don't like about Sky Safari is that I'm almost suspicious that some of the stars are almost randomly generated background stars, because the patterns don't always match up with what I see. And it's not just like a once or twice deal. It's I think they may be off on some of these stars. You can also change the magnitude of the visible stars to match what you're seeing in your eyepiece, so that you're not, so that you get the full benefit of what you can see as far as finder stars in here. All right, so there are three really good sources of information on this. There's an instructable where a guy walks through exactly what he did to his telescope. And then this guy, Rob Nabholz, has Home Built Astronomy, and it's really great. He's built all kinds of gizmos and does a very good job explaining how he did it. And then that thread on cloudy nights, it's 15 years old. It hasn't been locked by the moderator. It just keeps going and keeps going. All right. So does anybody have any questions?
That's a good presentation.
Thank you. Appreciate it.
Yeah, not to put you on the spot, Ed, but I'm kind of curious, kind of like what kind of skills would somebody kind of need to put something like this together?
If you were going to do the circle, the azimuth circle, the easiest thing you can do is, like I told my son, I said the diameter of the bottom of the porta mount is 2.6 inches or something. And he just laser cut a wooden protractor, and I just dropped it over the base of that. And then there's not even a pointer on there. I just look at one of the corners of the thing, and I can turn it.
Okay.
So no skill there. And then for altitude, if you had one of these magnetic angle gauges, just drop it on top. Daryl, your 8-inch Dobsonian has got a steel tube on it. You could just bonk right on top. And I would say the hardest thing to do would be to build that big angle scale, azimuth scale for the base.
Sure.
Yeah, I'll concur with you. I posted some images recently on our Facebook page of some galaxies that I could see with my camera. So, I mean, if you want to put your camera on and you can pick them up and do EAA, but I couldn't see a damn thing visually with my 6-inch. So, I mean, I'm really disheartened now, thinking, oh, maybe I get better when I get my mount so I can use my 8-inch. But
Yeah,
with a 10-inch now, you can't see it. Boy, we're in trouble. But
yeah,
try
I'm not that good at spotting galaxies, though.
Yeah, but try putting your camera on there, even the Bonnie SV305, and just use it not to take pictures or images, but just in SharpCap, do a live stack. You'll be able to see them.
Okay.
And that's the way I've been doing it in Little Rock. Whereas when I'm at the RRO, I can see the galaxies visually in my eyepiece. So it's a big difference.
Well, I've really enjoyed for finding double stars and stuff like that. I mean, I can knock a lot off a list, even in my front yard, where I don't think I can see Delphinus from my front yard. So, but there's some double stars there that were on the list, and I got there because I could see the other brighter stars in the neighborhood, so I could get close. But that helped me zero in.
Yeah.
On that.
All right. Anyone have any other questions for Ed? Well, folks, it is 8:02, so we've got about an hour and a half before the sun goes down. If you want to get your gear ready and get outside and start observing, I suggest you do that. I'm going to get out and try and do some imaging of the sky with my phone camera. And anyway, that was a great meeting.
And I wanted to mention, Dara, I've really enjoyed the images you've been posting by using the National Telescope. That's really cool.
Yeah, and I mentioned that before, and if none of you have taken advantage of that, you should. The NASA Micro Observatory network of telescopes, just Google Micro Observatory, and you can go there and use a robotically controlled telescope, tell it what you want to image, set your exposure time, what filters you want to use, and if the weather's clear wherever that telescope is located, and they have several, you'll get an image in your email the next day, and you process it. There's tutorials on how to do all that. So if you ever wanted to get into astrophotography, the easy way, the cheap way, then this is a good way to do it. So, yeah, thank you. All right, that's all I have. Anyone have any announcements that they want to make? Or?
Could I show a quick video of a star party? You got me thinking about star parties.
Yeah.
It's you've probably seen it before, some of you, but okay, let me. Ooh, how do I do this? Okay, here it is. All right. So I need to. Oops. All right, I'm fumbling around with the.
Yeah, just share screen at the bottom.
Okay. Share screen.
Mm-hmm.
And then optimize for video clip. Share. Okay.
There you go. We can see your desktop. And there's
Okay.
the video.
Can you see my video?
Uh-huh.
All right. This one's a fun one. This is our setup at Okie-Tex back in 2012, I think.
I'm sorry, where is this again?
That's the Okie-Tex Star Party. It's at the very end of the Oklahoma Panhandle.
Okay.
It's a fun one.
And
there's another one.
And that's not too far away. I mean, that's drivable.
Yeah, it's not bad. It's a good one to go to. I think I might have one more I'll show you. Just playing okay through everybody's bandwidth. You never know with these things. Well, there was a meteor with a smoke trail or a crane. Then we had Aurora one night, which was fun.
oh, wow.
Yeah, that's the skies there are like Bortle, whatever the darkest one is. Here we go. That may be just like the other one. Let me see what else I got.
But I'll reiterate to everyone that the Texas Star Party is going on right now, and if you want to watch it virtually, you can online tonight. They're going to be doing a star party later on this evening. They've got guest speakers. They started around 6:30, I think. I know David Levy was speaking. There's several others that are involved as well. And you can go back and watch the previous night's versions on YouTube.
It's kind of funny. You can see everyone packing up. It's getting late. Less lights. All right.
So what is the nearest city? Just kind of curious to that area. Or
To-
town rather.
To the Star Party.
Mm-hmm.
Oh, how big a city do you count as a city?
Well, I don't mean, I guess a gas station and McDonald's would count, so.
Yeah, I mean, there's a little town called Kenton that's right there, but it's very small and probably like 50 people.
Okay,
The nearest town of any significance is Boise City, which is not visible from there. It's not even a light bill.
sure.
But I've actually seen visually the Gegenschein from there.
Oh.
And the
That's impressive.
yeah, it was difficult, but I finally decided I did it. Now the Texas Star Party is equally dark. It's a bigger Star Party in that more people attend. The Okie-Tex is not quite as big. I kind of like that in a way, but everybody needs to go to one at least once.
I was going to point out that the Okie-Tex Star Party is going on October 1st to October 9th this year.
There you go. Are they going to actually do it?
Yeah, they say they're still ironing out their COVID protocols, but yeah, they are going to do it.
Okay. Perfect.
It's probably closer than the Texas Star Party too. I'm guessing just because, the one is on the other side of Texas and diagonal, whereas Okie-Tex is kind of straight
Yeah,
out I-40.
yeah, you have to do some maneuvering to get down to the Texas Star Party.
It's a cool place though. It's a really neat place to go to.
Yeah.
All right, well, thanks everyone. I'm going to head out and we'll get ready here to head out, and I'll see you guys later.
All right.
All right. Well, good luck, everyone.
Thanks, everybody. Bye.
All right.
Bye.